Hey, what's going on everyone? This is Big Brace channel. Good morning, good evening, whatever you may be. In this last poll I created, the majority has voted for creating a mathematical compiler in C. Don't worry guys, if you are in the minorities, I'm going also to make tutorials on these apps to be published each week. I'm going to disappear probably only 2 weeks in the month of July. I need to take some time off. I have to read a lot of scientific material in computer science in general, but in C and Rust in particular. I'll be back in probably mid-August till end of August. I'm not really sure, but I will let you know. You will find a video or a post or something that will inform you for sure. C has become my favorite language to explore and train in. I mean, don't get me wrong, JavaScript is great, Python is great, Haskell, Lua, C#, Rust, all of the other languages, you name it. But C for me is very special. C for me is something that it's magical, it's magnificent. C is the mother of all of the C-based programming languages like Java, JavaScript, C#, C++, all of that. It was created by the great, the magnificent Dennis Ritchie in 1972 at Bell Labs. And by the way, I find it a terrible mistake to make movies on Steve Jobs and totally ignoring people like Dennis Ritchie, Ken Thompson. These geniuses, they are humble. They actually have created everything that we're working on today. Linux, actually, the Linux system is based not on Unix, but on Minix, but still, Minix itself was based on Unix operating system, which was created by Dennis Ritchie and Ken Thompson. So I find it really a terrible mistake to make movies on Steve Jobs. Also ignoring people like Dennis Ritchie and Ken Thompson, underrating them is a terrible mistake. I find it totally unacceptable. During my free time, I like to create simple, yet powerful programs. I can't call them applications, but programs like the one that we're going to build today, a mathematical compiler with C that's going to do addition and subtraction. I'm going to talk about that in details. And when I see a question saying, what is C useful for? I feel somehow, I can't say insulted, but I don't understand the question, you know. It's exactly like you're asking me, what's the benefit of learning the multiplication table? Now back to the question, who is programming in C today? Take a look. Unix actually is written in C, and big chunks of Windows are actually written in C. And as Linus Torvalds said, that nothing comes close to C when it comes to software engineering. The Linux kernel is fully written in C. And for those of you who don't know, Linus Torvalds, the creator of the Linux kernel, is also the creator of Git. So if you didn't know, there you go. Git also is written in C. Blender is written in C. Adobe Photoshop. The CPython, the Python interpreter, actually and interestingly enough, is written in C. And finally, MySQL also is written in C. The program is a simple compiler-like application for evaluating arithmetic expressions. Eventually, you can improve upon the program and add division, you can add multiplication, you can do whatever you want. But just for the sake of time and the purpose of this tutorial, I'm going only to show you the addition and the subtraction. This compiler is going to consist of 3 main components or 3 main parts: tokenization, parsing, and code generation. These are the main 3 components of the compiler, of any compiler, but just keep in mind that this is a simple compiler, right? I'm going just to demonstrate to you how a compiler works in a very simple terms. So you need a tokenizer, you need a parser, and a code generator. The 3 main components in any compiler. So what it does that it takes an arithmetic expression as an input, let's say 3 plus 4 minus 2, and it's going to break it down into tokens. So this number is a token, the plus is a token, the 4 is a token, the minus is a token, and the 2 is a token. All right? And it's going to interpret the tokens to evaluate the expression. And then it's going to generate corresponding assembly-like instructions. So let's say, for instance, that you have done 3 plus 4, right? That's going to be load 3 and then add 4. That's going to be the assembly-like instruction. So that's exactly what it will do. Again, it's going to evaluate. Again, it's going to take that arithmetic expression as an input. It's going to break it down into little pieces called tokens, and it's going to take each token and interpret it to evaluate the expression. In other terms, parsing. And it's going to generate the corresponding assembly-like instruction or code based on the arithmetic expression that you're going to feed the compiler. And of course, it's going to do the calculation itself. So it's going to give you 7 as a result. Yeah, maybe you can just make it like that to be consistent. So yeah, guys, I'm so excited to be coding this compiler program with you today. Thank you so much for tuning in. If you're new to the channel, please consider subscribing to the channel. Hit the like button, leave a comment, a feedback, a question, whatever you want to leave. And yeah, thank you so much again for supporting the channel. Without further ado, let's go ahead and start coding our compiler. Alright guys, welcome back. So I'm inside a file called main.c. I don't have anything else in that folder, just main.c. The readme.md, you're going to find it in the GitHub repo. The VS Code folder, just ignore that. That's because I've changed only in the colors of the bars, so ignore that. Alright, so first thing I want to write here that this is simple compiler in C. This is an arithmetic compiler for addition and subtraction. I'm going to type my name here or program. Right, also version 1.0. All right, and also I want to import libraries. So the first library that I need is the standard input output library. And that's going to be we're going to include the standard, standard input output. Where is it? Standard input output, there we go. That's the first one. The second one is for just the standard library functions that will have functions like memory allocation, for example. Standard library, there we go. Next, I need for a library for the character type functions. So particularly, I will need the is a digit. That's very, very important. So as we're going to see, that's going to be used in different parts of the program, but I'm going to bring that from the ctype.header or .h. And finally, I need the library that's used for string manipulation. So there are some functions in that library, which is string.h, and that's for string manipulation, actually. So that's for string manipulation. We're going to include that string, actually. Yeah, string.h. All right, and that's basically it. These are the 4 libraries that we'll need for our compiler. Next, I need to create the first component of the compiler. If you remember, the first component was the tokenization or the tokenizer. Actually, programming this was really fun. I will need to have different types of tokens. We said that we have a token for a number, for the plus and the minus, and also we'll need an end token. That's going to be the last thing in the string that you're going to type. So that's token end, if you will. And for that, I will need to have enumeration for those types of tokens. I will need now type def, and that's enum. Here I will need to enter those tokens. So the first one is token number. You can change these, by the way, I mean the names, no problem. Token plus, token minus, and token end. And I'm going to give that enumeration name of token type with the TT capitalized. Right, and that's absolutely logical because these are the token types, whether number, whether a plus, whether minus, or whether the end, the last token in the string. And following that, I will need a structure. That's going to be a structure to represent a token. So this token can be a number or an operator, plus, minus. So yeah, this is a structure to represent a certain token. And here I will have the type of token. So we need two things actually in that structure. We need the type of the token, whether it's a number, a plus, minus, or AND, and of course the value. So the value of that token, whether that token is a number or not a number. Let's say here token type, and also int value, the value of that token. Yeah, and that's going to be token. The structure, I'm gonna call it token. So we have the enumeration, which is the token type, and the structure, which is the token itself. Right, awesome. Now I will create a function to tokenize the input string. Whatever you're going to type, that's going to pass through the tokenizer. And the tokenizer is nothing but a function. So function to tokenize the input string. Now I will have my token structure, and I will just create here a function called tokenize. Tokenize, and that's going to take the input, right? So I'm going to have this as a constant with a data type character or char, and whatever the input that you're going to enter, because that's going to be more than one input. This asterisk means take whatever number of input inserted in that tokenize function. And the tokenize itself is preceded by that asterisk. Next, I want to allocate the memory, and that's why I've imported this standard library, the standard library function for memory allocation. So the memory allocation function is called malloc, right? I call it malloc. So memory allocate, and we're going to allocate a specific number of bytes of memory. So that's going to be 256 multiplied by the size number of the token structure. So size of, and here we will pass the token structure, and all that is going to be assigned to tokens. And the position initially is going to be equal to 0. That's actually the position in the tokens array. So, oops, I forgot to, of course, where I see here, don't forget the semicolon, that's very important. But now I will need to loop through the input string that you're going to enter. So you're going to type 5 plus 4, for example, right? We're going to code that here, simply just let me add a comment, loop through the input string. And we're going to have a while loop, while asterisk input, which means whatever the number of input that you're going to enter, because that's not necessarily 5 plus 4 or 2 plus 1 or 6 minus 2, right? It could be 10 plus 5 minus 4 plus 2. It's a series of calculations between addition and subtraction. So that's not only limited to 2 different digits separated by an operator. So we're going to check with a while loop, while input, if that input, but don't forget that this input actually is going to be a string. Whatever you're going to type is a string, not an integer by default. And that's why we will need the isDigit function to convert that input from a string to an integer. So we're going to wrap that like this, and also we will wrap the whole thing. So we'll do like that. So we're going to check if the character is indeed a digit. We're going to create a token number token. So I'm going to take the tokens with the sub position dot type, and that's equal to the token number here. And also instead of the type, I will have to have the value, and the value in this case is going to be, so what I'm doing here is that I'm converting the string to long. So long, of course, is a data type in C, right? And that's typically 4 bytes on the 32-bit systems and 8 bytes on 64-bit system. Of course, 4 bytes means 32 bits and 8 bytes means 64 bits. So I'm going to convert that to long type. There is a function called stir2l. So I'm going to take the string and I'm going to convert it to long. And inside here, that's going to be naturally the input and the character with double asterisk and the input, and the integer base is going to be 10. So maybe I can add a quick comment here. I am converting the string to long data type. And then at the end here, I'm going to increment the position by 1. So pose plus plus. Let's do it like that. Which means that I've added that character to the tokens array. Right? So this is only in case of that input is a digit. But what if that input is equal to plus? So else if the input, the input is equal to plus sign, right? What if that's the case? In that case, I'm going to create another token. I'm gonna call it token plus. The ones that we have actually created here in the enumeration, right? So I'm going to have here a token plus. So maybe I can copy this actually. And I'm going to change that from token number to token plus, right? And also I will increment the input and I will increment the position. And exactly the same thing I'm going to use for the negative sign. So I'm going to say here, else if the input is equal to negative sign. So if it's a negative sign, I'm going to paste that right here, just delete this. And that's going to be token minus. And again, we're going to increment the input and the position. And for any other case, which means that I'm going to skip any other characters, like spaces, for example, I'm going simply to increment the input, right? So here I'm skipping the or any other character. And that's basically it, guys, for the tokenizer. Just finally here, I want to mark the end of the tokens because I will need the token end, right? So mark the end of the token. And that's going to be tokens position. That's going to be actually the same as the type. So you can do like that. You can just put that down here and delete that. And that's going to be token end. And finally, I will return the tokens. And that's it basically, guys. That's the tokenizer for our compiler. That's the first part of our compiler. All right, so the first thing that I want to do in the parser definitions here is to create a function that it's basically going to parse the tokens and evaluate the expression. That's a function to parse the tokens. Here is number 1. That's the first thing. And the second thing is to evaluate the expressions. Awesome. So that's going to be an integer function called parse. And I'm going to pass the token with whatever the tokens are being passed. And also I want as an input the result. And the result should be an integer. So the result of that arithmetic calculation should be an integer naturally. So A in that function is the position in the tokens array. So the position also initially is going to be 0, it's going to be an integer. B in that function is conditional. The conditional says that the expression must start with a number, otherwise that's going to be an invalid expression. So you need to be careful because we are actually checking if the tokens sub position.type here is not equal to the token number, in that case we will have an invalid expression. So I'm going to return 0. And be careful, that's not an exit code. In Unix and Unix-based systems, which are basically written in C language, we have different exit codes, by the way. We have 0, we have 1, we have 2, and we have even more than that. 0 means success, which means that the program is executed successfully without any errors. 1 is a general error. It's actually a catch-all for any error that doesn't have a more specific exit code. And 2 is just a misuse of the shell, right? But that's not the case here. Return 0 here means false, means invalid expression. Once you're done with your conditional, you want to initialize the result with the first number. So the result here is equal to the tokens sub position dot value. But that's not all, because we need to add that position. And again, you want to use a while loop. This time you're going to loop through the tokens and evaluate the expression. So you're going to check out if the type of the position in that tokens array is not equal to the token end. While that is true, you're going to do several checking, several conditionals. So first let's type that while the tokens sub position dot type is not equal to the token end. You're going to check out if tokens sub position, right, dot type is equal to token plus. In this case, what you want to do, you want to add the next number to the result. We're going to increment the result by that number, or in other terms, you're going to add the next number to the result. And if tokens sub position dot type is not equal to the token number, in that case you want to return 0. That's an invalid expression. Otherwise, which means that if the tokens position dot type equal to token number, we want to add the token number to, or the value of that token number to the result. So result here is going to be incremented by tokens position dot value. Else if, so we'll need maybe to make like that, and we can make like this, and I will say here else if tokens position dot type equal to so that's going to be like that. Else if so yeah, can make like this. Yeah, there we go. Else if the tokens position dot type token minus, so that's going to be token minus. In that case, let me just minimize a little bit, right? In that case, actually we will need exactly the same exactly the same here, right? So let's just do like that. We'll copy this, we'll paste that in, and instead of the result incremented, we're going to decrement it. And that's going to be exactly the same case. Yeah, so basically we are checking if the position or the type of that token's position equal to plus, we're going to add it. And if that type doesn't equal to a number, we're going to just return 0, means invalid. Otherwise, we're going to add the value, and exactly the same thing, but in this case, instead of the token plus, we're going to check out if that's equal to token minus in this case. So this is exactly the same thing, exactly the same logic. The difference is in the result. Instead of adding, we're going to subtract. And for any other cases, we're going to return 0, which means invalid token. And here, don't forget to add to the position, add to the tokens array. And if all that is successful, we're going to return, yes, you guessed it, 1, which means successful parsing. Successful parsing and evaluation, right? Because that's parsing and evaluation. Now our last function is going to be used to generate assembly-like instructions from the tokens. So I'm gonna call this one generate assembly, or generate as if you want. I'm going to make it void. Void here because it doesn't necessarily will, return any value. It's going to just generate the code and print it to the console. So it's not going to return a value actually. So the input, of course, or the parameter is going to be for the token, and that's taking all of the tokens passed to the code, to the function. The position, the initial position is set to 0. And here I want to load the first number into the register. Now, if you don't know what registers are, please check out my second video in my assembly tutorials. I've explained registers in detail. So I'm going to load the first number to the register, right? So that's the first thing. So here I'm going to print, we'll say here load. That's going to be the first number. So we're going to load with the escape for a new line, right? And the tokens dot position dot value. Dot value. If I can type today. All right. So that's the first thing, and position, of course, ++. Right. Now I want to loop through the tokens and generate the instructions. So I'm going to have a while loop again. It's very handy actually for that type of operations. So tokens subposition dot type. I'm checking out again. Type is if it's not equal to token end, right? So while that is true, I'm going to check out if that type is equal to token plus. In that case, I'm going to generate an add instruction. So let me just add this comment. If the token is plus, I'm going to add instruction or generate add instruction. So let's do that. So position ++ as always, and I'm going to just print, where is it? So I'm going to print, instead of load, that's going to be add, and that's going to be exactly the same thing, tokens position dot value. And exactly the same thing for the negative. So that's actually going to be almost the same code. So else if tokens dot type is equal to token minus, in this case, right, that's going to be here sub instead of add. And finally, that's going to be position ++ in the tokens array, right? So basically that's our compiler, guys. We are done with our compiler, just remaining the main function. So let's go ahead and glue everything in the main function. And the first thing I would say in the main function is to have a buffer to hold the input string that you're going to type. So that's going to be of char data type, char input 256. Next, I want to prompt the user. You're going to prompt the user to enter the arithmetic expression. So let's print f, let's say here, enter an arithmetic expression. And I'm going to give him example 5 plus 4 minus 3. Next, I want to read the input from the user. So I need the input, right? And I need the size of the input also. So the size of input, and that's the standard input, right? And all of that, I'm going to just trap it in parentheses and have it as arguments in the or for the fgets function. Awesome. Now I want to tokenize the input. So we're tokenizing the actual input entered by the user. So let's tokenize the input. Okay. So now tokens, and that's equal to our function that we have created, tokenize, and taking inside here the input. Now I want the result as an integer, and I want to parse the tokens and evaluate the actual expression. So I'm going to have conditionals again, if parse, taking the tokens and result, right? So don't forget that the parse function is our second component of the compiler, right? So if that's true, we're going to print the parsed results. So going to print f, and we'll say here parsed result is equal to, again with the percent sign, with the escape new line sequence, and we're passing the result. Here I'm going also to generate the assembly-like instruction. So I'm going to invoke my generate assembly function, and I'm going to pass the tokens as an input. And if anything else, we're going to simply print an error message if this expression is invalid. So print f, I'm going to say here simply invalid expression. And if anything goes wrong, if anything is unexpected, we're going to print an error message, and that means that the expression is invalid. So I'm going to print f, and I'm going to say here invalid expression. And at the end of the program, we're going to return 0, right? Return 0 here means the exit code for successful execution, right? Not like the other one, the other return 0 that I've shown you earlier. This one right here. This means invalid expression, right? This also means invalid expression. However, the last one in the main function right here, this means successful execution of the program, that everything went okay. All right, awesome. Also, don't forget to free the allocated memory for the tokens, because we have 256, right? So we want to use the free function or free method, and of course, we will pass the tokens. All right, guys, and that's basically everything. However, there is one thing or one more thing that I would like to add to that code, which is going to be a small code block to remove new line characters if there are any new line characters. And that's actually going to be after the fgets, because what the fgets is going to do is going to store whatever the value of the expression that you're going to write. So here maybe we can have this removing any or new line character. So I will declare a variable called len, and that's going to be this the length of the string, or string length of the input, right? And let's actually, I forgot to, let's have this unsized type, size underscore t. This one is unsigned data type that's used to represent the size of objects in bytes, actually. It's the return type of strlen. So now I want to have a condition that will ensure that the string is not empty. Well, I can check out if len is more than 0, and the input sub len minus 1 is equal to a new line. So I'm checking if the last character here is a new line, right? By saying if the length is more than 0 and the input of the length minus 1 is equal to a new line, which means that this input with the length minus 1, this one here accesses the last character of the string. And as of course the arrays are 0 indexed, of course the last character is going to be at the position of length minus 1. That's the last position. And this condition actually checks if this last character is equal to a new line. And if that's the case, what we're going to type next is by replacing the new line character with a null terminator. And the null terminator is made like that, /0. That's a null terminator. So the input with the length -1, that's the last character, is equal to that null terminator. So /0. Alright guys, so that's basically our compiler program. Let's go ahead actually and open the integrated terminal and check out what we will have. Alright, let's do Control L to clear the terminal and let's compile our program. So again, our file is called main.c, so I'm going to use the GNU compiler for C. You can check out if you have it. So if you're running on, like me, if you're running on Windows subsystem for Linux, you should have it by default. That makes part of the Free Software Foundation or the Free Software Movement created in 1983 by Richard Stallman. So yeah, and you can check out the manual for the GCC. You can read the manual, you can read the description. So it tells you here that when you invoke the GCC, it normally does pre-processing, compilation, assembly, and linking, right? That's the compiler for the C language. But for now, I'm going to quit. You can read that if you have time. So I'm going to use the GCC, and I need an output file, and I'm gonna call it main as the main.c file. And it has compiled perfectly. If you will take a look to what we have, now you can see that we have an executable, right? That main file is an executable. You can go ahead and run your file. And here you're prompting the user to enter an arithmetic expression. So if you will do 8 plus 5, enter, you can see here that parsed result is 13, load 8 and add 5. Perfect. So our compiler is working perfectly, guys. It has actually prompted the user. It has parsed the value. It has evaluated the expression. It has tokenized it. Actually, the first thing, it has tokenized it, creating tokens for each component. It has parsed everything, evaluate the expression, and then generates the code. That code right here, that's an assembly-like code. Let's try that one more time. Enter an arithmetic expression. Let's say 100 plus 23 minus 45 plus 56 minus 79, whatever. Enter. A parsed result 55. So that's the result of that calculation. Load 100 because that's the first number as we have programmed it. Then add 23 sub 45, that's correct. Add 56 and sub 79. So that's it basically, guys. This is our compiler written in C. I hope it was useful to you, and I hope that by writing this program you actually have an open appetite now to learn more C. Thank you so much, guys, for watching, and I will see you in the next video.